So we've already seen in the previous webinar that the Corda ledger is made up of shared facts. And actually in true Corda terminology, we refer to these shared facts as states. And what we're going to talk about in this webinar is what a state is and how you can use them. So states represent shared facts. Can see here that we have a shared fact, which is an IOU, so an obligation for one party to pay another an amount of cash by a date in the future. And often there are some other terms associated with that, such as dealing with late settlement, for instance. So that's exactly what we've got here. We've got an IOU between Alice and Bob, and we've got Alice as the borrower and Bob as the lender. And you can see here that both of them have an identical representation of this IOU in their vaults. And you can think of this table as Alice's vault, and this table here as Bob's vault. And you can see that they have the identical representation of that data, but with some of the column names are labeled differently, as they both have taken different roles in this IOU, as one being a borrower and one being a lender. So let's talk a bit more about what states are. So states contain data about shared facts at a specific point in time. So this is important to know because obviously states or obviously facts, shared facts, need to evolve over time. For example, if we take this IOU between Alice and Bob, Alice might pay a certain amount of the IOU, so she might partially settle the IOU, but potentially there could be an instance whereby she's late at paying the IOU and incurs some interest. So we expect these shared facts to change as real world events occur. However, in Corda, because we use what's called the unspent transaction output model, once states have been created, they can't change. So we say that they're immutable. And obviously this conflicts with the nature of agreements, which are expected to evolve over time in response to real world events. So we need a mechanism for these states to evolve over time. And in Corda, what we have is we have this mechanism that allows new states to replace old states. So states always remain immutable. Once you created them, you cannot change them. However, what you can do is replace an old state with a new state. So for us to do this, what we do is we take the current version of the state, we copy it, and we make updates to the various properties in that state as required. It's important to note that obviously a shared fact, if it represents something that exists in the real world, it only has one state at any particular time. So once we create a new version of the state, we mark the old one as historic, and this is analogous to marking a Bitcoin as spent, if you know how Bitcoin works. And the spent Bitcoins, like historic states, are not considered on ledger. However, they do exist for the purposes of an audit trail. So we never actually delete states, we just mark them as historic or consumed or spent. And what happens is that you end up with a sequence or a chain of states over time. And that sequence over time represents the whole life cycle to date of that particular agreement that the shared fact is modeling. So how does this mechanism of marking historic states work? So if we have an IOU of £10 between Alice and Bob, and Alice wants to settle £5 of it, then she takes the original IOU represented by this grey box here and pays £5 to Bob. So what we're doing here is, instead of modifying the actual amount owed, we're adding a property on to say that Alice has paid £5 of it. So it's as simple as that. So it's worth noting actually that states can contain anything. In Bitcoin, Bitcoins represent scalar values of Bitcoin or of some currency. However, in Corda, states can be used to represent literally anything. Some things they can represent have been listed below. So typically we use them to represent financial instruments or multilateral agreements, typically bilateral agreements such as interest rate swaps or some kind of contract. But of course, they can be used to represent anything. So KYC data is there. It doesn't necessarily have to be an agreement, but more often than not it is. And it's worth noting that states are statically typed. That means that once a state has been created that is of a particular type, it cannot morph into another type. So a bond state is always a bond state. A CLO is always a CLO, and an invoice is always an invoice. So a state will have a set of properties that should model the real world instrument. For example, a bond will have a coupon rate, a redemption date, a nominal amount, etc. And that bond will always have those fields. So just to conclude here on states, states are immutable objects that represent shared facts, such as an agreement or contract at a specific point in time. So it's important to note that they represent an agreement or a contract or a shared fact at a specific point in time. and that they're immutable. If you want to create if you want to transition or evolve your shared fact, then you have to copy the old one, change some properties, and mark the old shared fact as historic. So let's talk a bit now about state sequences. So remember when I mentioned state sequence represents the life cycle of an agreement up to a point in time, then we'll see here how that manifests itself. So let's say we start with no agreement. There's no agreement on the ledger yet, but I think with this scenario we have Alice and Bob again, with Alice being a borrower and Bob being a lender, and they want to create a shared fact about some amount owed from Alice to Bob. So they do that by creating a shared fact on the ledger, which is a bilateral agreement between Alice and Bob, that Alice owes Bob £10 by the 1st of March 2017. And the event or the transaction is that Alice borrows £10 from Bob. Subsequently to that, on the 2nd of February, Alice pays Bob £5. So they both update this state object to represent the fact that Alice has actually paid £5 of it. Then we have to flip over to the next page where we have the same state as before, but now it's the 2nd of March, and you'll note that that's actually after the payable by date. So Alice actually here incurs interest of £1, but then subsequently she pays down the IOU. So she pays Bob £6, which is £5 principal and £1 interest, and as such the agreement expires. So that's not to say that all of this chain of IOUs or this sequence of IOUs has been deleted. They still exist in the vaults of Alice and Bob. It just so happens that this agreement where Alice incurred the interest was the last one that existed on the ledger. By virtue of the fact that there is no agreement now, we say that Alice has paid in full the IOU. Therefore, there's no reason for it to exist on the ledger anymore. So if Alice and Bob wanted to, they could go into their vault, they could dig out this audit trail representing the life cycle of the IOU from when it was first issued on ledger to when it was finally settled on the ledger. And this whole sequence represents the life cycle of that IOU. So just to reiterate the point, after a bunch of state transitions, you get a sequence of states, and each state represents an agreement at a specific point in time, with the head of the sequence always representing the current state of the shared fact, which should hopefully represent the real world if the ledger has been updated to do so. So the head is always current, with all the prior states being historic. So you can see here, as the state evolves over time, you can see that the unconsumed head, the non-historic head, is always the most up-to-date version of this agreement, with all the other states marked as historic. And we can say that this sequence is a shared fact life cycle. So just to reiterate, the life cycle of a shared fact or agreement over time is represented by a state sequence. And you can get your state sequences from your Corda vault. So just a quick point on the vault before this webinar ends. The vault is a part of the Corda node, and it tracks the heads of each state sequence. So remember, these state sequences can represent any type of agreement, but typically it's usually a financial instrument or some kind of contract. And the vault will know which are the consumed historic states and which are the unconsumed current versions of the state. So you can query the vault for all of the unconsumed states, and it will give you the heads of all of the state sequences. Or potentially you can query the vault by type. So maybe you want to pull out all Bs, all As, all Cs, or all Ss. Or you may want to pull out all states which meet a particular query which you provided to the vault. So you can think of the vault as the mechanism that keeps track of your current state of the ledger. So the current state of the ledger is all of the unconsumed heads of the sequences in the vault. So all the other ones will be marked as historic, but obviously the heads remain unconsumed. And it's worth noting that say here we got B and A. B and A represent shared facts. Therefore, there is an identical B and A in another node vault. Likewise with C, though potentially C here is a trilateral shared fact, so it's shared between three parties' vaults. And S is not actually shared, it's just a fact which the owner of this vault is keeping up to date for their own purposes. So you can see here that all these here are counterparty vaults. So just to finish, we can see that the ledger from each peer's point of view consists of all of the state sequence heads or non-historic states tracked in the vault. So if you want to get your current state of the ledger, which involves all different types of agreements, then you'll just pull out all of the state heads or all of the unconsumed states. And that will give you your complete picture of the ledger with all of the peers that you have transacted with.